Hi, everyone. We're continuing with lesson 25, and we're talking about the relationship between point estimates and interval estimates for a population parameter. Over here, you can see that with an interval estimate for mu, or an interval estimate for p, the corresponding point estimates at x bar or at p hat will be at the center of the corresponding interval. So these interval estimates will be symmetric about their point estimates. That's true with interval estimates for mu and for p, though not for sigma or sigma squared. In both cases, the margin of error is this distance between the point estimate, for example, the sample mean, and either limit of the interval. So try to think of three ways that you could calculate the margin of error. If I gave you the lower limit and the upper limit of a confidence interval, basically the confidence interval, in this case, a confidence interval for mu, how could you calculate the margin of error? Think of three ways you can calculate the margin of error, which I'm denoting by E over here. Well, let's go through these. And also, we will interpret the margin of error. Okay, so in example 2, we estimated the population mean of exam scores in a class. Our point estimate was the sample mean. X bar was 74 points. Or you could have calculated that from the interval, the limits of the interval. You can take the average of the two limits and get the point estimate, the sample mean. Our interval estimate is symmetric about the point estimate, 74 points, because this is an interval estimate for mu or for p. We have symmetry in those cases, though not for sigma or sigma squared. All right, now in example 3, we're talking about the idea of margin of error, which is this distance between the point estimate and either limit. Well, there are three ways to do it. In this example, you can take the upper limit. Let's see, do this in red. You can do the upper limit minus x bar, or 78 minus 74. So you could go 78 minus 74. That gives 4 points. That gives you the margin of error, which is 4 points. Also, you can take x bar minus the lower limit. You can take 74 minus 70. That gives you 4 points. Again, it's that same margin of error. And we have symmetry of this interval about the sample mean, the point estimate. A third way you can do this is that you can take the overall width. The overall width over here is 8 points. And you can cut that in half. So you can take the upper limit minus the lower limit, the entire width of the interval, which is 78 minus 70, or 8 points, divide by 2, you get 4 points. So there are three ways that you can figure out the margin of error, given the limits and or the sample mean. Now, the interval estimate here that we have for this population mean mu, this mean test score for the class overall, which we don't know yet, this can be written in terms of the sample mean, the point estimate, and the margin of error E. And this is because we have symmetry. So when we're doing interval estimates for mu or p, where we have symmetry, we can use that in order to more accessibly represent the confidence interval, in order for it to make more sense. So we're saying here that the population mean is basically the sample mean, give or take the margin of error. So the population mean, we're saying informally that it's 74 points, the sample mean, give or take 4 points. The sample mean, give or take 4 points. So realistically, the population mean could be as low as 70 points or as high as 78 points. It could be anything in between. Now, I need to clarify something. This notation, this plus or minus notation, because before, when you use this in your algebra classes, you may have used it in a different way, like in the quadratic formula. In the quadratic formula, when you saw plus or minus, you usually took both cases and accepted both cases, and there were two answers to your problem. But here, the plus minus means something different. It means give or take, basically. So our confidence interval for the population mean consists of 70, 78, and everything in between. Now, don't freak out at the issue of parentheses versus brackets. The way I'm writing it, it looks like an open interval. And this is pretty standard in statistics, but you could just as well write it as a closed interval. So we could say that the population mean could be realistically 70 points or 78 points or anything in between. Bear in mind that when you're doing things like using the quadratic formula back in your algebra class, you got two answers, and that was it, just two numbers. Bear in mind that the confidence interval here does not just contain two numbers, the 70 points and the 78 points. Here I'm kind of using brackets, sort of. It also picks up every number in between. So we're using this plus minus notation a bit differently from before in your algebra classes. Now, what are some ways that you can interpret this margin of error, 4 points? I'm going to go back up here. The margin of error for a symmetric interval estimate. Again, this applies to interval estimates we're going to do in this class for mu, a population mean, or p, a population proportion or probability. Our interval estimates will be symmetric about their corresponding point estimates, which will not be the case for sigma or sigma squared. But for a symmetric interval estimate, the margin of error, denoted by E, is the distance between the point estimate, in this case x bar, and either limit. That's why we could calculate it by doing either 78 minus 74 points or 74 minus 70 points. It's basically the difference between x bar and either limit, where you take the larger minus the smaller. The margin of error is always positive. So the margin of error, again denoted by E, is the distance between the point estimate and either limit. You go larger minus smaller. Also, it is half the width of the entire interval. That's where we took the entire width of 8 units and divided by 2, and that gave us the 4 points as well. Okay. Also, and this is somewhat new, it is the maximum likely distance between the point estimate and the true value of the population parameter being estimated. I just hinted at this before. What we're saying here is this. Remember that this interval estimate is an estimate for mu, a population mean. We're saying that we believe that the population mean is between 70 points and 78 points. And the point estimate happened to be at the sample mean, 74 points. But really what we're saying here is that we believe that the population mean is within 4 points of the sample mean, the point estimate. Okay, but at most we'd expect mu to be at most 4 points away from x bar. So at most mu could be 78 points realistically, or as low as 70 points realistically, or it could be anything in the middle. It could match up with the sample mean, although that's unlikely. Again, the margin of error, which in this case is 4 points, is the maximum likely distance between the point estimate, x bar, and the true value of mu, the population parameter we're interested in and that we're estimating. So we're saying that we think that mu is within 4 points of x bar, which is basically what this notation kind of hints at. Our estimate for the population mean is the sample mean, the point estimate, x bar, give or take the margin of error. And sometimes we prefer this form. In the homework, I'll make clear which form I prefer. This interval form where you indicate the limits of the interval, or this form where you indicate the central point estimate and the margin of error. The population parameter of interest could be the point estimate, give or take the margin of error. And again, this form would apply only to symmetric intervals. In this class, that means an interval for mu or an interval for p, but not sigma or sigma squared. Next, we're going to talk about why these interval estimates are often called confidence intervals, and that's next time.